Can you see my screen?
Yes, it's here.
All right. Hello, everyone. So we are from Dell. So basically, we are a five-member team. We wanted to do as SONiC AI capabilities. So every one of us, focusing on different aspects of the as SONiC AI feature. Senthil focusing on the architecture, myself focusing on the AI agents infra and live agent, and focusing on creating the SONiC backend infra so that you can query information, and then Uday focusing on SuziQ agent, and Ratna focusing on the SONiC doc agent. So I'll go over the details why these agents are required and how it's like in general providing the comprehensive data. So AI is, as we all know, AI is revolutionizing every field. So we are seeing unprecedented productivity, unlocking new capabilities, and all those things. But so what is it for SONiC, right? Let's say, does it make the SONiC developer life easier with swift answer for all the technical and procedure questions, or whether it can help to increase the user adoption by avoiding uh, knowing the internal details of the SONiC, or whether it can decrease the troubleshooting time overall, right? So what we have done is we have done some kind of research. So what we have come up with is basically the traditional LLMs have inherent limitations in their knowledge and reasoning capabilities as they generate responses based on potentially outdated training data. So legacy 1.0 can help little bit providing vector database based latest contact information to LLM so that when LLM gets the query, it can refer the vector databases and everything, and then it provides the comprehensive output. But again, it's again the static information, nothing real time. Again, you need to basically every time you need to update the vector database to get update the provide the good context to the LLM. So in contrast, what is trending today in the AI world is basically the agentic technology, also known as AI agents, which is RAG 2.0, is basically utilizing the tool calling on the backend to access the current information, optimizing the workflows, and autonomously create specific tasks to achieve complex goals. So whatever we have seen so far in the industry in the AI world, right, prior to RAG.0, it's all RAG is LLM can provide response to your query, but it's all static data unless you give a train the model with specific data set, or unless you provide a context information in the form of vector database or vectors, it's not really going to do any good job, right? So that what we have done is, okay, we have leverage. What if we leverage AI agents for some of our SONiC requirements, right? So we that's when we introduced SONiC specific AI agents to design to answer the SONiC queries. So the architecture itself, as you could see, there is a, GPT model, or it could be any model for that matter. So we have the LangChain infrastructure, and we have added multiple agents, and then we basically attach to the LangChain, and then it internally talks to LLM to get the reasons and then the action basically. So the LLM itself is capable of providing the reasoning. So for any query you give to the LLM, it basically checks whether the response that you get from agent, whether it matches the query or not, right? It checks, and then it contacts the, if it's not satisfying, then it talks to other agent and then gets the response back. And then if it's not satisfying, it talks to multiple agents unless it gets the right response for the query. If it's not able to, unlike in the traditional model, sometimes what it does is it hallucinate big time. Like if it does not know, even though there's no answer, in present in the LLM, but even then it will hallucinate big time, right? But whereas here, you are providing all the AI agents necessary to complement the data, the static data available in the LLM, right? So we have created many agents. One for the RAG agent, basically, okay, you load your config guides, whatever the PDFs or whatever the static information that we have for SONiC, you load it into the vector database using the embedded model, and then you have the RAG agent attached to that vector database, so that any documentation related query coming from the user will go to the RAG agent. And then any, let's say you want to have some information regarding the BGP or any interface related counter information, it will go to the SONiC agent. Or if you really want to go live system to see what exactly the problem is, there any critical messages, or is there any problems in the switch, that can basically go to the live agent. So this is how the AI agents in general work, right? So basically for a given query, it will go to the AI agent, first AI agent, for appropriately based on the description that you have for the AI agent, it chooses one AI agent, and then, it thinks about, what kind of query we can give for this particular prompt, right? Then it selects the appropriate tool. So you need to write the tool such a way that whether for a given query, let's say you fetch the VLAN information or BGP information, you need to have all the URLs defined in the tool, so that it executes that information and gets the response back, and then feed that information back to the LLM and thinks whether for this particular query whether the response is accurate. If not accurate, it goes to the next agent, and then likewise it goes to multiple agents until it gets the right response. So this is our basically the demo. We wanted to show it in the video as well. This is just a glimpse of like what exactly we have done, achieved so far, right? The first is basically, okay, what I have a fabric. I want to know the details of the fabric, right? I'm just giving the query, and it provides the information in the tabular format. It's basically what we are getting from the backend a SONiC agent is the unstructured data. The LLM can intelligently format based on the unstructured data and provides this information, right? And then I want to know the device details, the interface details for some of the interfaces in the SONiC fabric. It can provide that as well. So it's all unstructured data. It can now intelligently form a row columns and everything and do it. If it's a structured data, let's say you can get the JSON format output, then there is no need for assumption anything there. So you can accurately provide all the information in a tabular format. The other example is basically for a given ARP query, what are all the information presented across all SONiC switches in the network fabric. And then for the route information it can provide. What if you want something from the document, right? So you can ask such questions as well. So this is not only for the VLAN, it can provide FRR related commands also. As long as you load all those PDF documents into the vector databases, the RAG agent that is attached to the ASCII solution can provide all the information for you. The next is the you can say what is the memory usage on leaf one. It basically it goes to the SONiC live agent to get the memory related information. So it executes certain commands based on the LLM's reasoning. It executes such command, and then it contacts the right agent and gets the response back. Again, you can ask for like, is there any problem, any daemon exceeded in any of the switches in the fabric, that it can provide that information as well. So let me play a quick video on this one. So I'm starting the Ask SONiC AI Python code here. So it is basically providing the UI. So I'm asking a question here. Can I get a device information for my SONiC switches? So it executes in the backend. As you can see, what are all the URLs being executed in the backend, and how it's basically fetching the information, and it validates whether the information that we got is correct or not. And then the second query, basically, I want to know the topology, how my switches are connected. If you then basically it goes and selects the appropriate agent and gets the response back. And then I want to know the interface counter for a specific two interfaces across all switches. I'll see all the information as well, right? And then I want to know the drops on particular interfaces, right? Are there any drops in the switch, right? It executes all the interface information and then provides those information in the tabular format as well. And then I can say, okay, what if some complex query, right? I have a Mac. I want to know, whether where is this ARP entry and all those things, right? I can, get all those details as well. And then I have other complex query, for example, I can give for a given host IP, right? How does it work to reach the other destination IP? So what it intelligently does is like internally, it dumps all the route information available across all SONiC switches and then sees, okay, for a given route destination, what are all the tables it can take or it can look up in order to reach the destination IP. So it provides all the information. So as you could see, it basically dumps the entire database and checks against the routing information present for a given destination, and then it provides the information that, okay, for to reach a particular destination, you need to traverse via leaf 1, spine 1, and leaf 2. So that information is basically given. So this is all based on the raw data that we are getting it from SONiC switches. LLM determines that, okay, this is the all the information we need to look up in order to get the right answer for the question. And the next one is basically how to configure the BGP neighbors, right? Like I said, like you have the documentation agent. When you configure any documentation related information, it goes to the particular agent and fetches the data information. And then you have, you can say, okay, I want to go to the live switch and then get some information, right? In this case, it's I want to see some error logs, right? So here you will see it is executing right now and see whether is there any errors in the logging message. Okay, there is no log. Let me recreate that by like introducing a error in the SONiC switch, and then let us execute that the same command again, whether and see whether it is throwing any NTP related errors, right? I just restarted the NTP. I'm just executing the command again. Let's see whether it can provide whether it can detect this action in the UI, right? So it's again executing it. Okay, if syslog has the information that NTP got restarted, then basically we are executing all the commands, and it detected that yes, NTP daemon has been restarted on leaf 1, and it got the signal 15, right? So it's providing all the information like this. So for the past 2 days, we have we are happy to we have accomplished so many things. We with the help of agents, but you could create multiple other agents as well, not necessarily these agents for config mapping, right? You can, for a given third party NAS configuration, you want to change it to SONiC configuration, you could very well do it as long as you have the agents created and all the the relevant queries are added. So and then the model trained according to the conversion logics and everything, you could very well achieve it. And then pretty much with the limited agents we could achieve this much, but when you have more agents, more and more agents, it should help to debug your problems quicker. You don't need to spend hours. You could achieve, you could get the comprehensive summary of the your network barring in matter of minutes, if
Yeah.
not hours.
Thank you, Venkatesh.
Thank you very much.
Yeah. Judges, any questions?
Hey Venkat, a quick question. Apart from document munching and giving the example configurations, if I have
Yeah.
an intelligent ARC agent which can do exact operations, like for example, you said route to a particular destination, the
Yeah,
orchestrator knows which are all the leaf switches it has. It can query the route tables and it can munch the data and then give the output, right? So
that's correct.
where exactly are we getting benefited from these agents?
So Sindhil, you want to take up that question, or I can answer?
Go ahead, Venkat.
Okay. So basically, the agents, right? Not only the static data, you can get live information. So it reduces your troubleshooting time, right? Basically, what happens is, so you can ask multiple questions. For example, I want to configure certain things on the SONiC fabric, and I don't have that information in the LLM, right? What happens is it goes to the documentation agent and fetches the relevant information. Okay, what exactly the configuration I want to do in order to configure certain feature, right? And then it goes to the appropriate next agent to use the knowledge got from the documentation. It applies on the other live agent to configure the fabric, right? That's one advantage. The other advantage is basically you don't need to learn any languages, any specific CLI commands of the SONiC, right? So what the user can do is, okay, user can say in the natural language, okay, this is my VLAN. You configure on all network network fabric. So it basically internally figures out that what exactly the command that we need to use in order to configure the VLAN or VLAN member association or VLAN IP address association. All those things can be accomplished without even knowing what exactly the internal commands of SONiC, right?
Yeah,
And
my question is more about a network orchestration tool which are available right now. They can implement the same logic. They can pull up the route data on each leaf, and they can correlate how the destination to a particular prefix can be derived, right? So my question is more about if I can do it through an orchestration tool which doesn't use any AI tools, how is this agents helping you
So the
in that aspect?
okay, let me take that, Venkat.
Yeah.
Funny. So basically, what happens is you have to particularly code around all the logic in your orchestrator. Here, if you look at the agent, we have not coded anything specific to the logic what you want, right? It is using the React approach. Venkat showed a slide of thoughts and reactions. So basically, it reacts itself, right? It uses its knowledge from the LLM based on the wide knowledge it has been trained upon. So it uses a thought reasoning process to jump between things and then see figuring out how it needs to do it. We are not writing anything specific to what to pull or everything, right? In orchestrator, for each and every example, you have to code, right? Instead of doing any of those kind of coding specific to each and every table you want, this is pretty generic. It understands what you need to do. It understands, it jumps around between multiple agents. It can keep going across all these agents to figure out whether it has a right level of understanding, and then it queries automatically for you. We are not specifically coding anything specific to, okay, I have to go execute this kind of 10 set of REST API commands to figure out all these things, right? It doesn't do that.
So all this
It,
knowledge is built upon the built based on the documents that you provide, or anything else?
it's not only the documentation, it's about the LLM, what it's pretty generically trained. We just provide the context to it, right? We provide the context via documents, we provide the context via telemetry, we provide the context via live interaction with the switches, right? We just provide the context. So we are just helping the pre-trained LLM, which is already available, right? Either the GPT-4 or Llama or whatever it is, the pre-trained large language model. We are just helping the model by providing all the relevant context it needs. And then it jumps around all those things using a logic called React, right? It does the thought process and reasoning, and based on that, it's going to get you. So it's not anything is not it's not hard coded here. That's the main advantage, right?
Okay, so I'm just trying to draw the parallelism from the earlier demonstrations done by the using RAG tool. So that is, yeah.
Yeah, RAG is the previous version of it. Whatever you have seen in the earlier demonstrations, right? Basically, what Marvel showed with their agent, and then earlier
Explode.
demo also, right? So those are all the previous versions of AI. The RAG is not sufficient right now, so that's why people are moving towards agentic AI. So you can use much more powerful tools to get much better results. Right, that's a previous generation of. That's where it started. People started using RAG, but it doesn't cut it out. So this is kind of a RAG 2.0 architecture with agentic approach. Basically, this is an enhanced version of those things.
Okay, thanks.
All right. Thank you so much, Dell team.